Hello, and welcome back to my series on adaptive manufacturing. And today, episode 6, I'm going to be talking about what exactly does smart manufacturing look like, but more importantly, how to design it. Now, there's lots of elements to it, but one of the main things I want to stress for today is that actually it's driven by the business. All right, so it's business requirements, business benefits. Okay, so it's not just an abstract technological solution, right? It's actually, there's a reason behind why people are moving towards more adaptive assets. Okay, so here you can see in front of you the traditional monolithic line. Okay, and one of its drawbacks, one of the many drawbacks, of course, is change over time and adaptability. Now, traditionally, it's kind of made up of lots of segments of machines which are linked together with conveyor belts, puck systems, or whatever. The other drawback is they're normally from different suppliers, but there's no overarching architecture. Okay, so you normally have each system has a slightly different HMI interface, which causes human error. It means extra training and things like that. But another one of the key ones is next to the change over time. Really, is how many products can you run on this particular asset out of your portfolio? And then, of course, as time goes on, the portfolio gets bigger. And you normally end up having to take lines out to put new lines in that can run the certain products. And as I said in my last episode, that if you run the calculations on not being able to run all your products on all lines, the maths is actually pretty overwhelming. The business case for running all your products on all lines in a cellular way is actually quite overwhelming. So, enough of that. We're going to get back to it today. We're going to get straight into it. So, the traditional architecture, as you can see here, is pretty much it. This is copy and pasted across the land. But what I'm going to show you is, so there's an intermediate. So this is what I would call class 1 adaptive. All right. And it can run 50 to 80% of products. With some adaptation, it could run all products, but it's not quite there yet. So the things to note here really is that we've got a common transportation system. There's a good reason for that. And that's because the first rule of automation is not let go of your product, control your product 100%. And you can see where I've got the arrows, that means that particular module, that particular asset plugs into the transportation system to adapt what exactly it is you're making. Larger bottles, smaller bottles, big boxes, small boxes, whatever it may be, it doesn't really matter. And then it basically finds its way to a palletizer at the end. Now, I am going to explain a little bit more here. So what I'm using is the data structure, the physical hierarchy, which overlays the data structure. So we're not separating that. I've talked about this many times. The structure you see here is a layered representation of the S8895 model, which I'll jump onto in a minute. I'm not going to go into too much detail, so don't drop off. It tends to bore people, which is fine, but I've done it in a graphical representation because you kind of have to help people visualize what it is they're building, right? So with the class 1 adaptive manufacturing line and line cell, I'll come on to that in a minute, you're looking at 15 minutes, maximum an hour really, to change over for a new product. And that really is max. That's because you might be changing a lot of functionality on this particular line or cell. However, right, you can see a few advantages creeping in here. All right, so we normally have one type of HMI interface, which is incredibly important. There might be duplicates, but essentially it's the same. And we can handle new processes, new materials, new SKUs. So this is key, because if we start to come outside of the parameters of this particular the line or cell, we can change the modules. So longer term benefits, so this is key. So these business benefits, absolutely they're there short term, medium term they're there as well, but there's a lot a lot of long-term benefits. So this is why I'm coming on to them here. All right, so your connectivity architecture, once we start moving in this direction, doesn't change. Your data structure doesn't change, and these two things can't change. All right, if they change, if you try and change these halfway through, let's call it a project or one of the projects, sub-projects, you're in big trouble because you have to retrospectively change things. So what it does is it gives you a model, and it means you can cut, copy and paste lots of software. It also means you can get these modules from different suppliers. So there might be a supplier that specializes in filling equipment. There might be a supplier that specializes in labeling equipment. There might be a supplier that specializes in vision inspection systems. And these are common reasons, right, why you want to be having a choice of suppliers. But there's an overarching architecture which enables you to become truly modular. And this is the key to adaptive manufacturing, is being truly modular. So there's quite a few systems out there now which are bridging the monolithic to the class 1, which you can see here in front of you, where it is modular, but within a couple of days you can add modules, you could shrink it. And the transportation system itself is pretty adaptable. So, but generally we're on about how quickly can we change the functionality, adapt the functionality. So once we start doing this, the benefits start to rise exponentially, okay? Because we've now modularized the whole process. So if we change a process, add a process, all this can be accommodated. Now I could go on if I'm going to keep this shorter today. All right. So once we design this overarching architecture, we don't have to think about it again. This is the goal, because what this actually means is we can concentrate on innovation, not trying to constantly improve and adapt existing assets. We know where we're going, right? We've got a map, we're going to go there. All right. So this is one of the more managerial benefits of adaptive manufacturing, is that it becomes much more easy to deal with the roadmap. So this is pretty much as high as we're going to go for the minute. Okay, so I call it a class 2. This is about adaptable as it gets at the moment. There's not many people doing this, but there's a huge reason to do it. So if you look here on the right, you can see that I've got added benefits. So this isn't just the benefits, this is added on to what's below it. Okay, so changeover times can actually be 0. All right, we can chase product through, that's no problem. We can do CIP offline because our modules have been split down into other layers, but the fault tolerance on these systems is hugely different to the monolithic line. All right, there's better performance on the class 1, but the class 2, because we've chopped up those processes and those systems into things, the fault tolerance is incredibly better. The fault tolerance is orders of magnitude better because we actually don't have to stop production. Okay, so this is why I'm coming on to planned work in progress. Okay, so this is what I'm showing you here is a cell line. Let's just call it a cell, and what you can see here, we've got AGVs, AMRs, which are then in charge of bringing materials to the line, bringing raw materials to the line and packaging materials to the line, and then we're using AGVs, AMRs. Now this is what I'm calling decoupling. All right, I'm going to jump out now. This is a general design for a imaginary factory. However, what you're seeing here is the decoupling of processes and functions. Okay, so you can see we've got process, we've got transportation, which decouples it. All right, so the process can continue if we've got a problem downstream. We've got cells of the manufacturing, so this could be primary and secondary packaging. In this case, it's just primary. Then we've got transportation again, AGVs, AMRs. And then we've got our secondary packaging down here, all right, but they're all decoupled. Now the important thing here, we've got a storage and retrieval cell, right, which can store product if we decide that we want to reuse it later. So for example, we might not want to do the secondary packaging, not the case packaging, but the secondary packaging. We're going to leave that to the other date because the artwork isn't ready and they haven't printed them or whatever it is. But the bottom line is here, and this is where we come on to chiplets, which I'll reference again in a minute. This is where we decouple our factory processes to make us more fault tolerant in general, more flexible in general, okay? Now, this sometimes can put people off because it is quite a jump in thoughts, but as per my other webinars, you don't have to do this in one go. My whole thing with adaptive manufacturing, more modular manufacturing, is that you can merge that green and brownfield site because it's decoupled, can just slot into your existing assets. So let's go back over. I'm going to try and be quick. So this is for those of you who haven't joined some of my other webinars. So AMD for many years have now used chiplets with many advantages because it means you can be more flexible in building the end result, the functionality of the chip. It has many economic advantages as well. So this is a good analogy. I'm not going to go into too much detail there, but if I come back here, so this is pretty much a fully adaptive cell or unit, right? And like I said, changeover times could be about 0, on the fly changeovers basically. It's got incredible levels of fault tolerance. You can speed up your deployment, so this gets missed sometimes, is how different products sell differently in different countries, okay? So once you start to standardize on this cellular approach, if a product takes off over the other side of the rail, we're shipping modules, we're not shipping whole lines, because quite often, you know, by the time you've adapted to the market changes, the markets have changed again. And the other key point here, on top of the work in progress, which I mentioned just a minute ago, is lot size 1, MOQ1. So with this design, there's absolutely no reason why you can't do lot size MOQ1. Absolutely not. It might run slightly slower, but because you've got this extra layer of flexibility with your modules, as described here, look, so not only are all the modules plugged into the transportation controlling your primary packaging all the way through, we can adapt easily the function of the function. Right? Now this could be different fluids, it could be different powders, it could be different combinations, but the point is that we don't have to change a whole module, we can just change the segment of the module. So we can divide up more of the processes. Now there is space to do this, so this is an important point, so I'm going to just zoom out quickly. Please don't switch off. I know some people switch off when I start talking about standards, but the standards give you a strong starting point so that you don't change. You don't need to change. There's lots of people working hard to make sure these are generic. So this is the SE8895. I like this because this covers batch, process, packaging, and can be used for warehouse, everything. Now there's some key points here. Now this is because these standards were developed when the only real solution was the line. So this is the line over here. And this is why we have things like production line, work cell. So the work cell is really the machine. And then we have an equipment module potentially, or station as it's called by some. But so things are blurring. So I quite like production unit, because we're moving away from this cell line. Is it a line? Is it a cell? Okay, so production line and work cell works. That's fine. However, we just need to be careful about overusing the module. However, what this standard does, it gives us the equipment module can have modules. We don't want to go too deep, all right? But very quickly, if any of you out there wanted to do a deep dive on this a little bit more, give me examples and I can split it out quite easily. The point is, this is your map. It's for data, it's for assets, it's the equipment hardware hierarchy, all right? The two aren't separate. Data, communication, assets, everything falls into this. So back to where I was. So changeover time can be minimal, right? That's not an issue. When we split the functions, we can handle safety a bit easier, actually. Fault tolerance is as good as it gets. Because in actual fact, if you have a serious fault with one of the units, you can just swap it out with another one. It'll inherit all the appropriate parameters when you plug it in, and you can be up and running pretty quickly. So I've mentioned market deployment and work in progress, but what I haven't mentioned is mixed pallets and direct shipments. Okay, so this is why I don't separate adaptive manufacturing from adaptive logistics, is because if you get your plant correct, you can do the mixed pallets actually in the factory. Because you got this work in progress as well with storage and retrieval, what we're not doing is case packing so much, all right? We're doing temporary storage, some case packing, but we can be much more flexible with secondary packaging and rainbow pallets and shipping direct to customer. This is where it ties into MOQ lot size 1. And what we've also got to add to this as well, so the benefits are stacking up, and I haven't really covered them all here, is the longer term benefits. So because we're modular, we can scale up. Okay, who used to say we don't have 3 cells or 3 production units that can make all the products, right? One of them can be running MOQ lot size 1 and shipping direct to an intermediate before it goes out to the consumer. Or we can be doing more mass production on the second production unit and the first production unit, which is more traditional boxes on pallets. Okay, we can do those as well. So just to summarize here, looking down, all right, so today we've covered really where we are today. There aren't so many people down here in the class 1 area, but there are people doing it with huge benefits, short, medium and longer term. So everything I've done here has got a business benefit, all right? It's not just for the purity of doing great engineering, which it is as well, but that's not the real driving force, all right? Because our ultimate aim is to make the whole factory adaptive. So just to summarize on the last section here with the class 2 adaptive, that's really the holy grail of where we want to be, all right? This is totally possible, all right? And we'll have huge financial benefits for not only the individual factories, but as the enterprise as a whole. One of the main messages I'm saying today is why I've done this level, is because you don't have to do it all in one go. What is key is how the functions, how the units and the modules plug into each other to give you this flexibility. However, I can guarantee you that if you work with your team to divide up these more critical processes, say on primary, secondary packaging, also your processes, you can find how they can be split apart into sections. Once you do that, you've literally got your map for where you need to be in the future. That's really what this series of webinars is about, is to give you a direct path to where you need to be. So hopefully you found that interesting. Hopefully I've explained it well enough. On the next episode, I'll be going more into the financial calculations for the benefits as well as the costs over the longer term. So for today, thank you again and bye-bye.